Hello, welcome back to the Geography 300 Geographical Data Analysis video series for WVU. This video continues what we saw in the past two, looking at measures of central tendency, measures of dispersion or variance, as ways of characterizing or summarizing our data set. This takes this to this idea of summarizing the data to kind of a third level or another approach, looking at, as we see here, what's called the distribution of the data. To illustrate this, we'll start with a histogram. So here we have a histogram. Most of the values are pretty much the same. So we can then describe this both with, we're not going to get into the math, but a mathematical function that would look like this. So a straight line, pretty easy in that, and call it an even or equal distribution. The next one I'll put up, and there are many such shapes that we can use. The next one is one that's very common and does indeed relate to some of the previous concepts, specifically what's called the normal distribution. The normal distribution has a peak in the middle, symmetric. So you could kind of flip it over. Values above the mean are just as likely as values below the mean. And while this specific geometric curve has a pretty complex formula, it depends only upon the mean and the standard deviation. So we then can use the mean and the standard deviation to characterize a normal distribution. And it's such that a little over 2/3 of the data are within one standard deviation of the mean. If I go out two standard deviations, we're about 95%. So if I know my data fits this distribution, says it's normal, I tell you the mean, I tell you the standard deviation, you know almost all of the values are within a particular range of the mean plus or minus 2 standard deviations. As this says, this is part 1, that ability with the normal distribution to say it's within 2 standard deviations with a certain level of confidence, this will come back later. We can have other, as I said, other formulas, other types of distributions. I will now illustrate some of those. Again, not going to go into the math of all the different formulas contained, but to show you what some of these different distributions look like. Some of them are kind of based on the normal distribution. One of those looks like a normal distribution that's kind of been shoved off to one side. When it's shoved off like that, we would call it skewed. if it is, in a sense, shoved so far that the most common value, the mode, is also the lowest, we would call that a decreasing distribution. That as the values get bigger, the chance of finding them decreases. You may see the term geometric distribution. This would be a variety of the geometric distribution. I'm putting this here because you might see it in other things you're reading or other things you're looking at, but it's not going to show up that much in that term here. But it may be useful information as you go forward. In some cases, we can have a distribution that looks like two random or two normal distributions. In this case, it has two modes, a low mode and a higher mode. That makes it what's called a bimodal distribution. One example of this, you might think of, say, from human geography, places becoming more and more politically polarized. If I were to look at the proportion of voters for one of the main parties, instead of there being a lot of communities in the middle, as sort of communities and people sort themselves into Republican areas and Democratic areas, we could have two modes. One for the Republican communities and one for the Democratic communities. In physical geography, there are some species where, say, the size of that animal is strongly determined by that animal's sex. So the males of the species are one size, the females are a different size. That again could produce a bimodal distribution with one mode per sex. The last distribution I'll put here has no pattern to it. It would then be a truly random distribution. This, again, is something that exists, but we actually see that relatively infrequently. We see these other kinds of distributions much more commonly, and especially the normal distribution, much more commonly within our quantitative and our geographic research. For now, we will be looking mainly at the normal distribution. All of them, except for random, all of these, it doesn't always use the mean and the standard deviation, but they all can be described by a handful of numbers. Usually, it's like 2 or 3 different numbers that help us summarize and describe that distribution. The other of these, which is readily accessible, we can describe an even distribution by saying it's even between the highest value and the lowest value. That again illustrates our ability to use these distributions to effectively summarize our data. And each of these distributions, again, just looking ahead to what will be part 2, can help us as we start making our inferences in inferential statistics about the data. Here they are used to describe the data. They will come back in terms of statistical inference. So as always, if you have any questions, feel free to send me emails. Feel free to ask in class. And I will say farewell, and I'll see you at the next video. Thanks for watching.